All right. Hello, everybody out there. Welcome to the download, episode 12, our Community Tech Talks. We're so happy to have you with us. And we have a very special March presentation with the Ides of March. Ooh, very creepy. And then we've got Easter coming up and March Madness for people playing basketball and just a lot going on here. We've got an all-star presentation for you, so I will go right into it. And if you've been to our Tech Talks before, just a couple of ground rules. Please share everything that's going on through the hashtag HPCC Tech Talks on Twitter. Also, ask questions. There's an area right below the presentation where you can type in questions during the presentation. We will prioritize them and try to answer as many questions as possible. Also, we're going to have poll questions. So there's 2 poll questions for each presenter. We'll have a first question that we'll look at, and then at the end, we'll look at the second one, and we'll review those results. And also feedback. If you enjoyed this presentation or have any comments about this presentation, please leave it for us today or visit our blog for information about the event. And finally, if you would like to be one of our featured speakers in upcoming Tech Talks for 2018, please email us at techtalks@hpccsystems.com. So without further ado, I always have a pleasure, it's an honor and a privilege to introduce our Vice President of Technology, and he's also a RELX Distinguished Technologist. That's a big title, with LexisNexis Risk Solutions. I'd like to start off our Tech Talk with introducing to you Dr. Flavio Villanustre. Good morning, Flavio.
Good morning, Bob, and thank you very much for the introduction. That was a great introduction, and I always enjoy also working with you and covering these Tech Talks with you. We have a few community announcements. Some of these can be a little bit of a repeat of previous announcements, but the time is moving along, and we are getting closer to the 7.0 release. So I want to make sure that I let everyone know that we will have a 7.0 beta release planned for early Q2. This is a significant, I would say even a breakthrough type of release. There are some fairly interesting chunks of functionality that are added here. There is one in particular, and I won't go through all of the items that you can see now on the screen, but there is one which allows the HPCC platform to move some of the computations to remote systems. And this might seem like a little bit of an abstract description of what it does, but the reality is that this will allow us to do more effective use of computational resources when you are trying to do remote reads. But not just that, it could also allow to offload chunks of execution code to other components in the system. If you were to have processing some sort of compute ability in, for example, your storage, we could move some of the pre-filter into the storage and reduce the CPU usage, and of course, reduce the waste in moving all of this data through your cache hierarchy all the way to the CPU to discard it, to filter it in the CPU later on. So I believe that this is going to contribute to a significant speed up in many areas, and it will also make it more effective to use more cores out of the systems that you are running right now with multiple cores in the CPU. But it is not the only enhancement. There are many other enhancements. So stay tuned. Try to get a hold of the beta release as soon as we release it. Test it. Get back to us with feedback. We would like to see it used in many systems, as many different systems as can be, and get as many comments and ideas. And as you know, this is an open source platform, so anything that we can get from the community will help other members of the community as well. And certainly, we always like to get pull requests. So if you have some interesting code that you would like to submit, that is always very cool. Now, outside of the upcoming releases, and I mentioned the 7.0 beta very soon, 6.4.12, which is our gold version right now for the 6 line of platform. We have a few other piece of news. One is there is a new case study from 3Lock. For those that remember previous Tech Talks, we had them talking about the things that they have done to the this AI platform that they built for consumer type of suggestions or consumer interaction. We have also a couple blogs. One is on tips and tricks for ECL. This is the second part of the parse command. That's a very cool blog entry. And there is a nice one about the first hackathon the first ever hackathon that we participated on, which was a real success. This is we want to, by the way, reproduce this in other places and continue to do it because it was very, very good. It was a way to bring new community members and at the same time tap into many of these smart people in the participating in the hackathon. So take a look at that blog, and if you have any events that you think we should be participating in, please let us know. Just work with us, and we'll figure it out. Outside of this, our summer internship proposal period is going to close on April 6th. I said this before, but please remember that if you are trying to apply for internship, please do not sleep over this. Just get your proposal done, take a look at the list of ideas, or come up with your own ideas, but submit the proposal as soon as possible so we can take a look and start getting mentors and other resources aligned for that. And of course the ideas list is on the screen. You should know that. Otherwise, go to our HPCC portal and take a look. And if you have some concerns on how to write a proposal or what you should do or what the next steps are, please go to the Student Wiki. We have a very good resource there. For those that want to be mentors, on the other hand, there are a number of resources in this wiki as well for mentors. So please go take a look, and if you think that you could be a mentor, let us know. We really, really need mentors. So just come ahead and let us know, and we will get you involved as well. Now, there is one new community-wide event that we are running, and this is around planting trees. As you can see on the screen, we are trying to in some way incentivize good behaviors across the community and beyond, protect our Earth as much as we can, since we have only one. This is until Elon Musk can take us to Mars. So we need to care for our Earth, and for that we are making an event that aligns with World Planting Day on Earth Day. And we will be planting trees together with the National Forest Foundation on behalf of the community. So please participate. There is a survey for this. If you fill out the survey, we will plant a tree for you, for the community. So this is, I think, a good event, and you shouldn't pass on it. Now, last but not least, I have the great pleasure to introduce our speakers for today. We have Itama, and all of the speakers have been well known for a very long time in our community. Itama is one of those. They have been distinguished with community awards before, and he has been throughout his career as a student and also a professor, advocating and using HPCC in a number of ways, including using HPCC for his master thesis as he was in Wayne State University. Right now he is in Kaiser University, and he will be talking about the use of EDA, or exploratory data analysis, in educational research. He has a very interesting topic using some data on ninth graders, on high school students, and doing analytics on top of that data. So stay tuned. This is a great talk. But before going to him, I want to also introduce our next two speakers, or last two speakers, Ignacio, and again another speaker that has been involved with the community for a very long time, has received an award from the community for the community efforts, and he will be talking about a topic that is also very, very interesting. This is the processing of geospatial data on HPCC. This is identifying locations, plotting maps, calculating distances across different points on the surface of the Earth. This is a very, very interesting topic. There is quite a bit that is different from many of the other things that are normally done on HPCC. So I really encourage you to pay attention and go through that, and of course ask questions as many as you'd like. And last but not least, I have the great pleasure to introduce Bob Foreman, who introduced me, by the way. And he will be talking about the top 10 common ECL compiler runtime errors. This is a mouthful of a title, but in reality it's all of those warnings and errors that you get from your compiler, and sometimes you wonder what does it mean. There are some, and he will explain, that are quite obvious. Some are a little bit more difficult to understand, and there are the cryptic ones, the MP-link closed, for those that are familiar with this or have seen this error before. So without any more preamble, I will pass now the floor to our first speaker, who is Itama from Kaiser University. Itama, the floor is yours.
Thank you, Dr. Flavio, for that introduction. And thank you to all for taking time out to listen to this talk. My name is Itauma, and today we are going to be taking a look at conducting exploratory data analysis in educational research using the High Performance Computing Cluster, the HPCC Systems. Before we start, I'm going to ask everybody to take part in a quick poll. There will be another poll at the end of this talk. How strongly correlated do you think the identification with math is with the confidence in the ability to succeed in math? Here's the outline of my presentation today. I'll be talking about what exploratory data analysis is, its role in educational research, benefits of using HPCC systems, and visualization examples. I will then go on to explore the high school longitudinal study data sets. Imagine looking at a large spreadsheet of raw data and trying to determine the most important characteristics of the data, or the best way to analyze the data set. Looking at a long list of numbers can be tedious and uninteresting. One may get overwhelmed within a short time. This is where exploratory data analysis comes in. Exploratory data analysis, for short EDA, is an approach to data analysis that obtains information about a data set by allowing the data to speak for itself and show its structure and model. It starts out with a broad, open-minded overview of the data without any assumptions about the data. Patterns, trends, outliers are examined using visual and quantitative methods and then investigated to determine next steps or areas of research. It is an important first step in data analysis, often before any formal statistical calculations, although statistic techniques can be applied during exploratory data analysis. EDA is not rigid with rules or formulas. It looks at how data is examined and interpreted. The researcher explores the data set, determines the most important elements after examining the data. So, exploratory data analysis includes organizing and summarizing raw data, looking for important features and patterns in the data, looking for any striking deviations from the patterns found, and interpreting findings in the context of the research question. EDA also provides a basis for further data collection. EDA can be used to gain new insights into big data, explore the underlying data structures, detect missing data and discrepancies, detect outliers, check variables of importance, examine relationships between variables, assess optimal factor settings, select appropriate models, and check assumptions. Exploratory data analysis not only helps to summarize data in a meaningful way, but often reveals new ways to think about the data. It helps in refining research questions and sometimes reveals new questions. After exploratory data analysis, we are able to ask specific questions of our data. Techniques for EDA are usually graphical in nature, but may be combined with quantitative techniques. Data visualization methods help to discover data patterns to aid decision making. Graphical techniques used in EDA include using raw data plots such as matrices, histograms, and probability plots, and simple statistics plots such as mean plots, standard deviation plots, and box plots. EDA does not have to be limited to these techniques, but a researcher may devise new ways to visualize data. There are four major types of EDA: univariate graphical, univariate non-graphical, multivariate graphical, and multivariate non-graphical. Graphical methods, as the name implies, involve visual representations of data, while non-graphical methods usually involve summarizing statistics. Summary statistics. Univariate analysis examines one variable of interest at a time, while multivariate analysis looks at multiple variables at the same time to explore relationships. To start an exploratory data analysis, begin with univariate analysis. To convert raw data into useful information, we should summarize and then examine the distribution of any variable of interest. By distribution of a variable, I mean what values the variables take and how often the variables take those values. The beauty of educational research using quantitative methods is that each student can take a look at the same data set but come up with different research questions and choose to analyze the data in different ways. Data is awesome, and having a tool that makes it very easy to analyze makes it fun and interesting, and definitely very exciting. Statistics is a process where data is collected, summarized, and interpreted. It plays a significant role in social sciences, which includes the field of education. With statistics, data is converted to useful information. EDA can therefore be described as data visualization plus statistics, which supports better data decision making, valuable for educational research. Research is important for the advancement of knowledge in education and in any other field. Educational research is a systematic inquiry applied to collecting, analyzing, and reporting information to address educational issues. Research results can be used to describe concepts or observations, predict consequences, and determine the probability of a future occurrence based on knowledge from an earlier time, improve outcomes of interest, and explain occurrences. And it's important for advancing knowledge in education. With the advent of big data, machine learning is needed to build systems that can learn from data instead of rigidly programmed instructions. Learning analytics is a process of collecting, analyzing, and reporting data about learners to discover learning patterns and enhance learning to improve learners' performance and help educators improve their teaching practices. Data is collected from learning platforms and devices to create personalized data-driven learning programs for learner success. With this growing educational data collection, big learning analytics is needed. Researchers in the field of education should be encouraged to adopt more machine learning techniques to handle big data and will benefit from the use of HPCC systems. Statistical learning is limited because of the need to develop a hypothesis and make assumptions about the data before building a model. Whereas in machine learning, algorithms are flexible, run directly on the model, and output the requested features with the data speaking for itself. And this will lead to better discovery. Currently, SPSS, a statistical software, is mostly used in educational research, and it's limited in terms of scalability and big data. On the other hand, HPCC Systems is open source, scalable, and can handle both data visualization and data analysis, all integrated in the platform. Another reason I choose HPCC Systems is because ECL is a data-centric language that supports a wide variety of different data and value types. From my experience while working with images in ECL, I must say that ECL doesn't disappoint. The Visualizer Bundle is an open source add-on to the HPCC Systems platform and plays an essential part in conducting exploratory analysis. Good visuals help data analysts make better observations. HPCC Systems can also perform simple, descriptive, and inferential statistical analysis. In episode 4 of the download, Gordon Smith talked about the Visualization Bundle. Ever since then, I had considered how it can be used in educational research. The Visualization Bundle is an open source add-on to the HPCC Systems platform that allows the creation of visualizations from the result of queries written in ECL. Well, ECL stands for the Enterprise Control Language. Visualizations are an important means of conveying information from massive data. A good visual representation can help a researcher produce actionable analysis. A visually comprehensive representation of the information can help make the obscure more obvious. Pie charts, line graphs, maps, and other visual graphs help us understand the answers found in the data queries. Crunching big data is only part of a solution. We must be able to make sense of the data as well. Data visualizations simplify this complexity. The Visualizer Bundle extends the HPCC Systems platform's functionality by enabling the plotting of data onto charts, graphs, and maps to add a visual representation that can be easily understood. In addition, the underlying visualization framework supports advanced features to allow you to combine graphs to make interactive dashboards. An alternative way of visualizing data is with Tableau, which can also be integrated in HPCC Systems, as discussed in a previous episode. This I intend to explore as well. Visualization provides a unique view of data that can make it much easier to discover interesting structures compared to numerical methods. As said earlier, visualization plus statistics helps with data decisions. This combination makes HPCC Systems suitable for educational research. Working previously with the HPCC Systems Visualization Bundle, the HPCC Systems machine learning correlation and regression models were used to determine the strength of the life expectancy and happiness. Here are examples of the data distribution of single variables and a scatter plot of the relationship between the two variables. Exploratory data analysis using HPCC Systems is performed on the dataset of the High School Longitudinal Study of 2009, a national study of over 23,000 ninth graders from 944 schools in 2009 through their secondary and post-secondary years. The dataset includes information on students' experiences and trajectories from high school and their post-secondary career choices. The research question to be answered here is math identity associated with math self-efficacy? For this study, Math identity is the level of a student's identification with math represented by agreement with the statement, you see yourself as a math person and or others see me as a math person. While self-efficacy describes the level of confidence a student has about the ability to succeed. These are constructs present in the HSLS dataset. What is it about math identity and self-efficacy that is interesting? Well, it could be possible that the higher the level of a student's identification with math, the higher the ability to succeed in math. This can be a strong factor in students' decision to enroll in STEM programs. So let's find out if math identity is associated with math self-efficacy. Remember, EDA, exploratory data analysis, helps in refining research questions and sometimes reveals new questions. To begin exploratory data analysis, a CSV file was sprayed into the HPCC Systems cluster. For this demonstration, I am only showing a subset of the dataset. Record set filtering is performed with vertical slicing to project the variables of interest and horizontal slicing to stratify the data for further exploration. Here, you can see that three features are projected: math identity, math self-efficacy, and gender. Next, we query the data set. Let's look at one variable at a time. This is called univariate analysis. Simple descriptive statistical methods are employed, such as frequency, mean, standard deviation, and so on. Here, a total count of males and females in the dataset is computed. The correlation between math identity and math self-efficacy is calculated, giving us a correlation coefficient of 0.63. Interesting, and this answers the first poll question. Can this be different between males and females? That's another question identified. Interestingly, the correlation coefficient for females is higher than that for males. Here we visualize the data with scatter plots. We can see the outliers and we see why data visualization is important. In interpreting our findings from this exploratory analysis, it is seen that the effect of seeing oneself as a math person or being seen as a math person correlates with increased confidence in math, and this effect is slightly stronger for females than for males. This can be a strong factor in students' decision to enroll in STEM programs. I must mention here that correlation does not establish a cause-effect relationship. Other studies are needed for that. Thank you, everyone, for listening.
All right, Itama, thank you so much.
Here's the last poll. Would you consider using HPCC systems for exploratory data analysis? Now I want to turn over to Bob. Thank you.
All right. Thank you, sir. All right, Itama, while you look at the questions from the audience and prioritize the ones, because some of them during your presentation I was looking were already answered. Let's look at the first poll result. Just to review, the question was, how strongly correlated do you think the identification with math is with the confidence in the ability to succeed in math? And we had two results, 41% strongly positively correlated, 58% positively correlated. We had 0 for the 3 bottom choices, not correlated or negative. So everyone was positive in your first poll results. Okay.
Awesome.
Let's move on to our questions from the audience. And The first one we're going to cover right here, what are the benefits, Itama, of using ECL in educational research?
The enterprise control language has great benefits. It is a data-centric language that supports a wide variety of different data and value types. From my experience while working with images in ECL, I must say that ECL doesn't disappoint, and I see that as a very significant benefit. Thank you.
All right, and here's another question. What are you currently doing with exploratory data analysis, EDA?
That's a great question as well. What are you currently doing with EDA? So I am using EDA for my research in education analytics to gain new insight into big data. Educational data can be regarded as big data because large volumes of heterogeneous learning data are being generated worldwide. In education analytics, patterns are discovered from generated data. Big data analytics methods are thus used in education analytics in learning environments and provide endless possibilities for personalized learning. Each student has a unique combination of background, interest, and strengths, which can be used to create optimized learning environments. So that's what I'm currently doing with EDA. Thank you.
All right, thank you so much. I think one of the questions was already answered. Do you use the HPCC Visualization bundle? And you already, in your presentation, had said yes. I think that's about all the time we have for the questions. We'll go ahead. Let's look at the other poll question. Let's take a look at that. And that poll question, again, was, would you consider using HPCC Systems for exploratory data analysis? Well, this is no surprise. 100% said yes. So, excellent. Thank you, everybody, for replying to the poll. And Itama, thank you very much for your presentation.
Thank you so much, Bob. And thank you all for listening.
Continuing with our concept of visualization, now I'm going to introduce from all the way across the pond, from Ireland, coming to us live from Ireland, from Dublin, is our HPCC ambassador. I've known Ignacio for quite a while, a good friend of mine, and it's always good to talk to him and visit with him. And his talk on big data and geospatial analysis with HPCC Systems. Ignacio, how are you, sir?
Very good, thank you. Thanks for your kind introduction. Right, I mean, it's good to be. It's easy to be as passionate for HPC when you have learned from the best, right? I learned from Bob so many things. As he said before, lots of things going on now in March. HPC releases. He mentioned March Madness. I love basketball. It was Pi Day, and then yes, in Ireland, St. Patrick's Day. So yes, my name is Ignacio Calvo, software engineer in lead in LexisNexis. And I'm going to give you an introduction to some concepts on geospatial, how we can use them with HPCC systems, and a few use cases. At the end, I will answer a few questions, but then if I can get to answer yours, feel free to reach out either by email, LinkedIn, or using the handle that you can see there in Twitter. So then, what's geospatial? Well, you can read the definition here, but effectively, if you are running analytics on data with any geographical or spatial aspect, you can get a benefit of this. So if you think about that, I would bet that most of you have somehow this kind of information. If you have a database or a data set with customer addresses, you can easily use any of the geocoders in the market and then turn those addresses into coordinates and get some insights or infer some kind of market segmentation. And then nowadays, in the time of Internet of Things, there's a lot of GPS data to be collected, where people spend the most time or where they drive, so that you know where to build a petrol station or even now how they drive, so that they can get a discount in their policy. And then satellites, they generate a lot of images for us to process. And then there are other markets like risk analysis, that's what we do, detecting particular crime patterns, improved transportation, logistics planning, fraud detection, etc. So, quickest question for you. How many of you have any kind of geospatial information or any address data or coordinates, etc. in your datasets? You'll see the poll in the bottom of your screen for you to answer. So, let's continue with some history. So the first documented case of geospatial analytics is attributed to Jon Snow. Oh wait, I mean, not the Jon Snow from Game of Thrones. He knows nothing about geospatial, but the English physician who worked in London mid-19th century, trying to figure out how cholera was spread. You can see that map there. So at the time, people thought that the cholera was spread through the air. And to prove them wrong, he got a map of London. He started adding markers for each case of cholera and realized that most of those cases were clustered around certain public water pumps. So he convinced local authorities to act on it and save some lives, which, given the resources that they had back in the time, they just could remove the lever from the pump, and that was it. So now that we can know that we could save lives or make money, what's next? So first, you need to understand your data. So it may only be the case that you have customer addresses, or you could have some data sets, like a shape of a river, as you will see on the map. And this geometry will come in a particular format or projection or coordinate system. We'll see what that means now. So formats, vector versus raster. Vector data is the one that you will see on the left. It's made of lots of geometries, that's points, lines, polygons, representing real-world information with coordinates. So cartographers will use polygons to show us some boundaries. They could be, for example, a building footprint. They could be agricultural fields. And then in the map, you could see some areas with a higher definition than others. And they can be as accurate as we want, but they can be processing intensive if geometries are complex. Raster data, so we can see an example on the right-hand side. So they are composed of pixels. Each pixel will have its own value that somehow you can translate into specific meaning. For example, given a pixel in a satellite image or in any kind of image, if the color of that pixel is blue, it could be that that's on water. If it's brown, it could be on the ground. Well, but an example closer to reality as we could have in our data could be that we could have number 5 if the location is with high risk of flood, or 0, for example, for low risk, and so on. So that's good for satellite data. We must keep same degree of resolution across all the data set. Doesn't look great when displayed because it looks pixelated when we represent it, when we display that in our interface, and it must keep a value for each cell, so it can become unnecessarily large. So I'll try to make you think with another simple question, just for fun. Look at the map in the representation. What's the size of Greenland compared with Africa and Australia? What do you think? It's fine if you get it wrong, but I'll show you the intention behind this in a moment. So please answer below what you consider the closest answer to reality. So we said that you need to understand your data in terms of format and projection. So what's a projection? So projections are used to represent the world in ways that we can process. So believe it or not, the Earth is round or close to an ellipsoid, and maps are flat. So this is what we use in order to represent the locations on the surface of the Earth into a flat plane. So you can see this picture, different ways of doing this. I think it's quite intuitive how we go from a spheroid to a flat map. So there are different types that you may have heard before. That's like the GPS, latitude and longitude, well, not technically like a projection. It's more like a coordinate system. And Google Maps will use its own coordinate system too, its own projection. So, in the next slide, we can see Peter projection versus Mercator. So the first one in green, that's the map that we will see in green. That will be Peter projection that was created in order to provide an accurate representation of the area of the countries, the proportion of them. On the other hand, kind of in blue, we will have Mercator. It was used to be more accurate with the boundaries of the countries, so that sailors would rely on their maps to sail across the sea. There are different kinds of Mercator projections. Oh, well, okay, so this is actually this is a kind of spoiler alert. So I don't know if you answer in the previous poll. We'll find out at the end. But projections could be misleading, right? I mean, you can see what happens if we project the actual size of Greenland over Africa. So you can see that in red. So the reality is that Africa will be 14 times as big as as Greenland, and Australia will be 3.5 times as big as Greenland. So, yeah, this is because Mercator projection will be representing the Earth on a flat map. Reality gets distorted, and it's just a representation. So, projections to know about. So yes, so the one that we mentioned, that latitude and longitude coordinate systems, WGS84, that's a good approximation for the world, but it's not always the best for a specific region. It's not, as I said before, technically a projection. And then Mercator, I mean, it's good if you look at a particular place in the world that this projection is intended for, but it gets worse as you go far away. Yeah, as we mentioned before. Number one, back in Geospatial. So sometimes you are trying to represent a location, which is supposed to be a building in a city, and then you find out that it's somewhere in the middle of the sea. That could be because we are looking at our data. We have our latitude and longitude. That means your X and your Y, but be careful because latitude is actually Y and longitude is actually X. So, we could have problems with that. I try to remind myself that X goes with longitude as in word extra long. So, now that we understand our data, so what's next? Well, not too different from what we would do with other HPCC processes. So, first, we said we need to understand our data. So is it a vector or a raster? We will upload it into our system. We will use Thor, our massively parallel processing platform, to build our indices so that we can deploy them onto Roxy. So then, some time ago, we asked ourselves what we would need to bring our geospatial processes into HPCC. So we came up with a few requisites. So one would be that we need to apply spatial filtering predicates and answer different questions. That means, is my point within a geometry? Do two polygons overlap? What's the distance between 2 points, and so on. Spatial operations using vector geometries. What's the union or intersection of two polygons? What's the resulting geometry out of it? The spatial reference projection and transformation. How to transform, for example, what we saw about a Mercator projection to latitude and longitude. How to handle data in different projections. And then reading compressed GeoRaster files. So the answer to this was just importing a few C++ libraries. So HPC has always been great integrating different systems. Itauma mentioned Tableau before. There are many other. There are different programming languages, for example, R. But in this particular case, the C++ integration has always been great in HPC. So we are looking here at some libraries like GDAL, Geos, Proj4, which are a reference in the geospatial domain. So we are completely sure that we are going to get all that we need, and our calculations will be completely accurate, or as accurate as they could be. So now let's go very quickly through a few different examples where we deal with different types of geospatial data and how we would do that with HPCC. So in our case, quite often we'll get customer policy data along with their addresses. We will geocode it, that is adding latitude and longitude so that we can represent that on a map. Peril tag, this means answer the question, is this property in a flood area, earthquake area, etc., and enrich the data in a few other ways. That's easy because HPCC is great in just in CSV, that's straightforward operation. And then we can use geospatial functions or predicates to answer that question, as I said, is this property inside a flood data or polygon? But then how do we ingest these polygons? So in our case, they come in the form of GML files or XML files. GML will be a subset of XML. Again, this is easy because we could be using HPC the XPath function. There's a lot of documentation out there, a lot of material about how to do with XML files. And once that we ingest the data in a way that HPC can process it, we build our indices in a way that it is easier for us to query them. For example, we have a complex geometry, and we add what we will call a bounding box. So that means along with the geometry, we add a simple rectangle or an envelope, if you want, that will contain that geometry. So before we check if a point is inside a complex geometry, we will check if it's inside that bounding box. If it is not, it will save us from expensive calculations. If it is, then we will apply subsequent geospatial geometry predicates. So depending on the case, we can build different kind of indices to query our data. So they can be in the form of quad keys or geohashes, which are good for aggregations or for calculations, or calculations in terms of accumulations, or they can be R trees, which are good to find all the geometries in an area. So for this one, this is a kind of a representation of what an R tree would be. So we will be that tree in which the root will be the biggest rectangle that we can see in black around that. That will contain all our points or polygons. So then we'll have the branches with smaller boxes, and then we'll have the actual geometries or records as leaves in the tree. So this way, we can quickly prune large portions of data without going through the full data set. So here we can see the flow of in this diagram. So first we ask at the root level, does this query polygon overlap our box? If not, we just return an empty set. If it does, so we iterate through the branches, pruning all the data that we don't need to look at. And this is great because we can, because of the tree structure, we can scale up to large data sets and still get subsequent responses. So on the other hand, we were talking before about raster data. So we can have a different way to process this raster data. So it usually comes in the shape of a bitmap image, right, or a TIFF file. We must tile all the raster images into small manageable areas so that they are easier to manage. Again, here it will be handy that the index that we have has a resulting record. So we will have the raster itself along with its bounding box, and then the grid position and the raster. So first we need to, so in order to query that raster, we need to figure out what tile we will need to look at. So we extract that blob of information. That's what I'm representing here in this grid of full of colors. And then we extract, once that we extract the blob, we extract the required pixel, So in the example, if we find that we need the pixel in the second row, so in the first column, so because the raster tile size is 8 by 8, as we can see, 64 cells, then we know that we need the value in the 9th position in the list of cell values below. So we skip the first row, that's 8 positions, plus 1, which is the first column. So we get the 9th position. So in the list of cell values, we interrogate the pixel for its value and see the value is 1. So we interpret it. Maybe it's a location with low risk of flood or crime, and then we return that to the user. So this slide is just an example of how to display that raster data, how that would look like. And if we want to display it as a bitmap, it can be a little bit pixelated depending on the resolution. And then the final index, how it will look like. So some fields that we can see there, some columns will be related to the tree structure. So in case that we want to store that in a tree because it's large and we want good performance in our queries, then the bounding box that I mentioned before, and then the geotiff blob itself contained in that raster blob. So I understand there was a lot of information in my representation. So as a technology person, I like going back to my desk, reproduce all the steps by myself, and play with it. So here I will refer you to a post written by Andrew Farrell called In Pursuit of Perils. You can find the URL in the links section, which will refer you to the entry in the HPCC system blogs. There it will tell you how to import the geospatial libraries that we mentioned before into your HPCC cluster and illustrate some of the different possibilities with an example. Right? Imagine that we have a data set with points which represent buildings. So using the typical project and transform, we can enrich the data and find out which of them are in a flood area, how far away they are from a fire station and a police station, and calculate some scores depending on this. So we can do that using very simple geospatial functions. So please go through it and then do that yourself, because you will see that very easily, how that works. So that's what we have been doing for a lot of time, but especially when composing this presentation, I created my own example, a simple example and if that was within minutes. Again, we have a data set of points, and we want to know if they are within a flood area that we can see there in blue. So looking at the example, it looks that it doesn't. Yeah, that's fair, but I could combine it with another data set of buildings. So in a couple of lines of code that you can see above, we can see how simple it is. We just filter the data set of points, of locations. As we would do with any other kind of filter, as we would filter for a field value. And we ask about the blocks where our points are within. So specifying the geometry that we are using in this example will be just normal latitude and longitude. And then we will filter again for all the resulting buildings that overlap or has any interaction. That's the function or the predicate name that we have with flood areas. That's very simple. So I spent several years creating big data solutions with geospatial capabilities. And every time that we needed to architect our system, we asked ourselves, will this technology be powerful enough to process all the data? Does it have all the spatial functionalities and precision that we need? And often the answer was no. I mean, traditional databases wouldn't be powerful enough to run our big data processes. They wouldn't be able to scale nicely. And other big data solutions, they wouldn't have any spatial capability at all. So HPC was the right platform to solve our needs. It gives us efficient parallel processing, all the horsepower that we know from Thor. Because of its ability to import libraries from different languages, we have the best spatial functionality that we could possibly get from GDAL and other libraries, giving us good coverage of functions and spatial predicates, fast ingestion in Thor, support for different formats, as we could see before, and sub-second queries, as we know from Roxy, which is our known data delivery engine. So, times for questions now, but as I said before, please feel free to get in touch with me offline if I can't answer now. Turning to Bob now. Thanks for your attention.
All right, Ignacio, thank you so much. Wonderful presentation. While you review the questions from the audience, let me review the poll results. We had 2 questions. I'm going to go through both of them right now because you had one of the questions right in the middle of your presentation. So we'll go through both of them right now, and then we'll conclude with your questions. So question number 1 was, of course, do you have any kind of geospatial information or addresses in your data sets? And, of course, we had 28% with just geospatial only. We had 57% with addresses only. And then we had another 14% with both. So good representation there. Most people work with addresses. 14% of the group work with both geospatial and addresses. So that was our first poll question. The second poll question, which was trying to trick you, let's see how many people fell for it. What's the size of Greenland compared with Africa and Australia? Well, we had 9% that said they're almost as big as Africa. Another 9% said half the size of Africa but larger than Australia. 18% said as big as Australia, but 63% of you weren't fooled. 63% of you said none of the above, and that was the correct answer. So well done to all of our attendees in the audience. And let's go to the questions from the audience. Ignacio, ready? Question number 1, is there an open source bundle for geospatial data processing that can be used for this?
Okay, so sorry, maybe I missed to say that, but so all the libraries that I was referring to before, they are open source. Well, we know that HPC is fully open source, the community edition. But then the libraries that I mentioned before, they are referenced in the market. They are all, so GDAL and Proj4, I think that they are MIT licensed. Just it's GPL, so they are open source licenses that no problem to use them for your own applications, for your own profit. So it's all for you all to use.
Okay, thank you. Next question, is there any work towards supporting the new Google Plus codes for address and lat-long mapping?
So I'm not 100% sure that I understood this. We can catch up offline. But so any kind of, well, if you have like an address, like a street address, you can use maybe Google Geocoder to turn that into latitude and longitude. In case that you get latitude and longitude, happy days, because that's a known coordinate system. If what you get back is, or what you have at the moment is Google Mercator, well, that will be, I think it's 3857. That's a known coordinate system, like a projection, if you want. So yes, you just pass that in as a parameter as you would use, as you would do within any other type of data.
All right, thank you. Let's do one more. From the blog on Geospatial, I can understand HPCC support geometry objects for all polygon or point features. Will HPCC support any other geospatial data types like GeoJSON?
Okay, so if you have a look at the blog post, so it is not native support that we are giving for spatial data. Well, we are using those libraries, and then you can build your wrapper on top of it. So what we are using at the moment in our implementation is usually well-known text format. It could be anything else. Basically, well, X and Y or latitude and longitude. But then when we ingest that, so our providers or our customers would send that in any kind of other kind of format. So it's probably part of the ingest process if you want just to parse that. I mean, GeoJSON is very easy to parse. So it will be just a few lines of code to parse it in the ingestion process if you find that GDAL it wouldn't be very, very good wrapping up that type of data.
Okay, thanks. There's one more question. It's more of a technical support question. I'll leave that for that person. Ignacio, you see that question there, and maybe if that person would email you directly, you can help with maybe importing the geo libraries into the Eclipse IDE. So that's another question I guess we can just tackle offline. So,
sure. I mean, not that we will be able to answer, each of them, and then, if it's more like technical support, then, it will be probably like a little bit tricky to answer that. But yes, please get in touch, LinkedIn, Twitter, or email. That's fine.
All right. Thank you so much. Ignacio, wonderful presentation. You're coming through loud and clear from the Emerald Isle and getting ready for St. Patrick's Day over there, which I think every day is St. Patrick's Day in Dublin anyway. But thank you so much, sir. Thank you for your for attending and presenting at our Tech Talk this month.
Thanks, Bob. My pleasure.
All right. Well, we're going to segue right into the final presentation, and I have the honor of presenting this, our ECL tip of the month, top 10 common ECL compiler runtime errors and how to correct them. So, first poll question, which this is like poking the bear. What do you think about the ECL compiler messages? All right, so the answers are below on that screen. Just your general opinion about ECL compiler messages, and we'll take a look at that result at the end of my presentation. All right, so when this tech tip came around this month, I was trying to think of a good topic, and just it came to me that after 7 years of training, we discovered that many errors that people see when learning ECL are common. So myself and Richard Taylor in our classroom environment, we get a lot of errors that are commonly occurring. So, we said, well, let's put these together into a list. Let's talk about the common errors that occur. All right, so a lot of these errors are easy fixes, but it's important to understand what the error message is saying and what in turn needs to be corrected. So we're going to take a look at that. Now, first of all, just a little background here about the types of errors. You can have two categories of errors. One is a compiler error. That's when you're doing a syntax check and you'll see the error pop up before you submit the code as a work unit. The second type of error you'll get is an error that after you've compiled correctly and you're not getting any errors syntax-wise, when you submit the job to the cluster, these are runtime or system errors that will prevent a work unit from completing. And again, a lot of these are often easily corrected. All right, so without further ado, presenting the top 10 ECL compiler runtime system errors. And I want to thank, first of all, also Jim DeFabio, who's out there, Richard Taylor, to help me compile these errors. And let's talk about number 10. Number 10 is called the work unit assassin. Well, we had some chatter going around the groups where someone was getting this error and they couldn't figure out what was going on. So it was a system error Thor abort. All right, this was a runtime error, so they were submitting their job, and then at runtime they were getting this error returned. What was causing it? Well, somebody killed or aborted your work unit, simply. So again, on the cluster, someone saw your job. Maybe it was running too long. Maybe it was tying up the system. Maybe a lot of other work units were backed up, so they had the administrative rights to abort your work unit. So the fix to this one, of course, is find out who killed you and why, and then restart your work unit when everything is all clear. So that was our Thor abort. Number 10, the work unit assassin. Number 9, if you've ever been on Facebook and been unfriended, this is the unfriended node error. But this is the one that Flavio was asking about before we started our talk. Well, famously documented, MP link closed. All right, so first of all, what is MP anyway? Well, you know, I thought, is it multi-link protocol? Is it the Minister of Parliament for those of you over in England? No. MP, according to our HPCC development team, is an abbreviation for message passing. So a message passing link was closed on a particular IP address, and the particular node had a problem. So that's what's causing the problem, or that's the type of problem that you're seeing, is that one of the nodes just stopped responding. The causes, though, are a little more difficult, and this is why this is a hot topic, MP link closed, because most of the time it could be an out-of-memory error. It might be a network issue, could even be one of the nodes going down. That's more of a rare occasion, hardware fault, or sometimes a version bug. Sometimes we get a new release and some code that you've been running for many, many months, all of a sudden MP link closed. It could be actually a bug in the version release. So the fix for this is, well, a couple of things. You can review your slave logs and your system logs configuration, check your configuration for C++ leaks, and if problems persist, if you get this MP link consistently, we'd like you to open an issue in the Jira issue tracking report. So that's number 9, which we call the unfriended node. Number 8, local limbo. All right, in class a lot of times people will bring in their laptops, and all of a sudden they come running up to me in a panic and they say, Bob, I'm getting this error, compile link failed, and all of a sudden their work unit number is showing the capital L in front of it, and then of course, the date and the time and everything else. Well, again, this is a compiler error. And very simply what happened was you lost connection with your cluster, and so by default, the ECL IDE reverts to a local target, which says, okay, your the actual cluster is on your local machine, and so it's trying to talk to the ECLCC and some other components in there and communicate. And so, of course, locally it can't find the linker, and that's why you're getting that particular error. So the fix for this one, of course, I tell people to go back, restart your ECL IDE, and then verify your cluster connection. So a lot of times what they're doing is they've got their laptop and they're connected to Wi-Fi, and so they, for some reason, they might lose their Wi-Fi connection, which severs the connection with the cluster, and then all of a sudden their job reverts back to a local mode, which will then cause this compile link fail. All right, so here's some example of some code. You'll see that, you'll know this if you get this. First of all, try to change your target back to either Thor or Roxy or HTHOR. And if you can't change your target, that means you've lost connection with the cluster and you need to reboot. And again, the work unit itself with the letter L is indicative of a local target. Number 7, we had a tie in errors. These two errors are very closely related. Need to supply a value for the field, or the transform does not supply a value for the field. So one of the things I do like about the compiler is that the compiler sometimes will give you some really descriptive messages on how to fix your code. So not only does it give you a syntax error, but it says, you know, this is what you do you need to fix the error. So let's talk about these. What do they mean? Well, again, these are both compiler errors, and the cause, the first error, need to supply a value for field, is normally in a table where your field is missing, or a field requires that you have in your table requires a default value. And the second error in the transform, where it's not supplying a value for self.fieldName, of course, that's, again, obvious. The target output of the transform has a field that you're not referencing. And I'm going to show you an example of that right now. So, of course, the fix to both of these is to get the default value for the table and make sure your field is referenced in the transform. Here's a couple of code examples. First of all, here's the table. And you see in the record structure, we have a field called rec ID. Now, sometimes people would create a table and they would just have the field only without the definition operator. And so then they'll get this error that says, need to supply a value for rec ID. And the person goes, well, I haven't really, I don't know what my rec ID is yet. I'm just creating a placeholder for it. So even 0 or a blank value for a string is considered to be a valid default value. And then that satisfies the table requirements. Moving on to transforms, here's an example that we use in class where we've got a left record set from from a SLIM file. We have a right record set from a lookup city state zip, and then we have an output which is kind of rebuilding the record structure together. So in the output, which is this file person's layout, you've got fields that are not part of either one of the left and right of the join. So they have to be explicitly referenced inside the transform, like the marital status and the dependent count and so on. So sometimes, and again, my old friend Greg Whitaker, who is an ECL developer out there, he one time warned us about sometimes be careful about your shortcuts there at the bottom of the transform when you're doing a self is defined as right or a self is defined as left. What that does is cover all the other bases, all the other fields that you didn't explicitly reference inside the transform. Any matching fields from input to output will then get automatically just piped from the input of the join to the output of the transform. Number 6, divide and conquer. All right, what do we mean by that? Well, this is kind of a simple error. You'll get an error that says global dedupe with all is not supported. And some other statements like iterate and I think sort, and there's some other ones that have a global option that sometimes the compiler will give you an error on that. This error comes out at runtime, so the syntax will be, in most cases, will be correct. And then when you run this, you'll see this error pop up at runtime. Now, the cause of this is because the compiler detects that using a dedupe with all is a very processor-intensive operation, and so it is asking you to break down your data set into smaller groups to run more efficiently. So the simple fix to this, of course, no matter how small your data set is to group your target data set and then run the dedupe on the group reference. And that will then allow you to do a global dedupe with all. Now, global dedupe with all is normally used for small record sets like 10,000 records or less. In most cases, you're just going to use a normal dedupe for larger data sets. Number 5, data set hide and seek. Okay, what do we mean by that? Well, this error is missing logical file. And every new ECL developer will sometimes have this problem. They'll and they're just not understanding why they're getting this. And it happens at runtime. Syntax is correct in their code. They run this and they just are getting this missing logical file. And what does that mean? Well, again, the cause of this is that the file name you entered into the dataset declaration simply does not match the name of the file that you sprayed or output. So there's two ways that you can create a file in the cluster. Of course, you can use the ECL wash or the DFU to spray a file from the landing zone into the cluster, but then you can also use the output statement to output a file to the cluster. The fix for this, of course, is to find and correct your typo and make sure that the file that you spray, the name of the file matches the name of your dataset declaration. And a lot of times people forget the use of the tilde. So here's an example of that. You see, in this example, the person output with a tilde, and so that overrides the base folder of the cluster. So the base folder of the cluster normally would be Thor. So if you didn't use the tilde, the name of the file that would be on the cluster would be Thor : class : etc. And so the dataset statement below references the tilde. If you had not used the tilde in the output statement, then your data set would have Thor : class : and so on. So just, again, mind the tilde, make sure that you're using the proper use of the tilde, and that normally will correct this problem. Number 4, no data set to read. What is this one? All right, file.fieldName, no specified row for table file. I think a lot of you have seen this from time to time. It's a compiler error, and what causes it? Well, the code is trying to reference a field value from a single record when the only thing in scope is the entire data set, or a field may be out of scope when you're using a parent-child denormalized data set. So the fix for this, of course, is to modify the definition to retrieve a single record in scope. Here's an example of this. Here's some ECL that shows you the exact, this error was, I actually went on our training cluster, was looking around at some errors, I found this, and I said, wow, perfect. I mean, this, one of our students that was using this came up with this error. So, and here's what happened. This is one of our lab exercises. They were trying to work with a Boolean definition, and then we were just trying to run the Boolean definition. And so the Boolean definition was saying, I don't know what value of trade type, you know, you're running this right now. I don't know what trade type value to use here. And if you had corrected that, then it would eventually give you a report date, no specified row for that. So it's just, it's giving you the trade type error because that's the first field that it encountered. And that's what the compiler does. But really, the whole record needs to be retrieved properly. So that's the issue here. You can't run a Boolean definition because it simply doesn't know what value to test at that particular time. All right, number 3, we had a tie. And this is one of my important topics that we talk about in training. Data set layout does not match published layout, and published record size for file does not match coded record size. I used to get a lot of emails from students who attended my class because I really didn't go over these as deep as I needed to, and the last few months going over this stuff, the emails have diminished, which is kind of, that's good to know. Well, a lot of times if the data set layout does not match the published layout, people are just completely flustered about that. What's causing that? And again, these errors happen, they're system errors, so they will happen at runtime. They're system errors. The cause of this is, well, due to the compiler. In HPCC, the most important thing is the data. Not only are we fast, everybody, but we're also accurate. So accuracy is critical. And so if you output something using a record structure and then you try to define another record structure that doesn't match exactly, and there's 2 things we're going to look at here, then the compiler will give you one of these 2 errors. And the fix, of course, is to make sure that you've got the correct field name, position, or value type for the record structure that is referencing your data set. So here's an example. Here's some ECL code. You see on the left, we have the record structure that was used to output the record set. So we have a field called CSV_ID that's highlighted. There's also a field highlighted called zip code. The first error that you see on the top, data set layout does not match published layout, would occur if on the right side you see that the developer didn't want to use the underscore in another record structure that was referencing the same data set. So they tried to change the field name thinking it was going to be a harmless change in the same position, it's the same type, it shouldn't be a problem. But no, that will be a problem. The compiler doesn't like to guess. The compiler needs to know exactly the field names that you output. If you want to change the field name to CSVID, then change it over on the left and then re-output, run the output again to the cluster, and then you can change the field name. So once again, it's just the information that's out there, the metadata out there that the compiler just doesn't like. The other error, of course, this one's simple. You can take the zip code field on the left was actually an unsigned 3, and the developer forgot, and he put a string 5 in there for the zip code. And this one's kind of really self-explanatory. It'll say published record size 31 for file, blah, blah, does not match the coded record size 29. So that size error is something that's a little more easy to decipher than the one in the top data set layout. Also, if you change the position of the field, that's going to cause a data set layout error as well. So be mindful. be mindful. Now, the best solution for this is just have a common record structure for that's pointed to from all of your ECL code. So if the person would have used the layout in that module on the right as the output basis, then there's no way that they could go wrong. So again, have a single source for your record. Don't copy and paste record structures around your repository, because then you can get into this data set layout problem. All right, we're moving up to number 2. We have our action retraction. Okay, now this one's kind of easy, but a new user will sometimes see this and wonder what's going on. Definition contains actions after the export has been defined. One of the rules in ECL, as a compiler error, one of the rules in ECL is that you can't mix exported definitions with actions due to side effects that could possibly occur. So the fix for this is either, remove either the action from your ECL code or remove the export. All right, so we have some example code here. We have the someone here that was getting this error. They were trying to export a definition and then output that definition in the same ECL file. And of course, that just won't fly. So to fix this one, you would either comment out the output, or you could comment out the export and then run the output on export output. So a lot of times what I'll do, the trick, because ECL code avoids white spaces, you can just hit the enter key right after the export and then comment out the export itself to run a test, and then take the comment out again when you want to restore the export, and then comment out the action. So anyway, exports and outputs cannot coexist. And so a lot of times people also have a problem with multiple exports. And the rule is, in a typical ECL file, you can have one exported definition per file. And someone says, well, what if I have multiple exports? What do I do? And the solution for that is the module. But then the module sometimes can give me my number 1 error, which I like to call module mayhem. And I'm calling this number 1 because everybody gets it in every single class that we have, and it's real simple. Here's the error. Module and the module name does not export an attribute main. And it's actually an error, but then it comes out as a warning, which then people are confused. They're like, am I getting a warning or am I getting an error? An error normally means it's something critical. A warning is something that, well, we're just going to warn you about this, but you can still run your code. But in this case, the code stops. You actually will get a runtime halt on your work unit. Of course, the cause of this, it's a runtime error. The cause of this is your module has multiple exports. You need to tell the compiler which one you want to run, or run a specific export inside of a builder window or another BWR file. All right, so the fix here is to use a builder window BWR file to explicitly drill down to your definition. And you can also rename one export definition as main, which is not recommended. So let me show you that. Here's a module right here that's got 2 exported definitions, def1 and def2. And so, of course, someone tries to hit the submit button up here, run it, and they're going to get the red X, and they're going to get this error that says does not export an attribute main. Now, if you had changed one of these to the word main, it would actually run, but that's not recommended because, of course, there's just other issues involved with that. You can open a BWR or a builder window and drill down to def1 by saying folder name .module demo .def1. Okay, and that would be the way to drill down to the particular exported definition. So there's our top 10. There was a couple that I want to call honorable mention because everyone always asks a question about these guys, and they're warnings. This one's kind of popular. Compiler server mismatch, and they get nervous about it. Is this going to cause a problem? Normally, if your cluster is a certain version and you've installed an update to the ECL IDE and you've got a more recent version, sometimes if it's a minor mismatch, it's not going to be, well, almost all the time, if it's a minor mismatch, you're not going to have a big problem. The one that you really should be mindful of is it's a major mismatch where you're using a version 5 cluster and you're trying to run the version 6 ECL IDE. So normally you should then sync up. You should either have an IDE that is matching the server version of your cluster, or tell the system administrator to update the cluster to the most current version. So one of those two to get your cluster and your ECL IDE in sync. All right, so that's one warning. The other warning we have here is another one. This one's kind of one of the popular ones. Everybody sees it when they're using the open source ECL IDE. They get this warning that says SOAP 1.1 fault, blah, 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 HPCC processing occurred, and they're wondering what's going on. After talking with Gordon Smith, he told me that this warning that appears is before open source, all clusters used shared repositories. So there was a check that we use when the ECL IDE connects to the cluster to see if the repository is a shared repository, one that's using a repository on the cluster side of things. Since everything is a local repository and our training clusters are local repository, when anyone ever starts up their ECL IDE with a cluster that does not use a shared repository, this warning will pop up. And again, to fix this warning can be safely ignored if you know you're using a local repository. So we're just about at the end here. Here's a summary of the top 10 again. So this presentation will be made available if you want to summarize everything that we just talked about. And to conclude, many compiler errors are common to everyone and can be easily analyzed. As time goes on, your exposure to these errors will point to quick and easy solutions, and knowing what to do and where to go when you can't decipher a message is critical for your productivity. So I hope I've touched on some errors that you might have seen in your own ECL careers. That's my last poll question. Out of the top 10 messages just presented, how many have you personally experienced? How many errors have you seen like this? And just kind of curious about that, because we see them all the time in class. Some of you that are outside of the classroom may not have, I just want to know how many have you seen this, have seen these errors that we had on our list. All right, so let me go over to the poll questions first. Let's look at our first poll result. Yes, I figured. What do you think about the ECL compiler messages? I hope Gavin's not online because this would be very depressing for him, but only 14% said mostly descriptive, 42% said rarely descriptive, and the other 42% said that compiler messages were like an Indiana Jones puzzle. So, all right, so point taken. That's why we did this presentation. I wanted to maybe clear the air for some of these errors that you were seeing. And while the second poll is being tallied, let me just take a look at some questions from the audience. All right, let me see here. Let me go ahead and prioritize this. I love the funny descriptive names and classification of the errors. Have you written this in a blog or white paper that I can use as a reference? No, not yet, but certainly, that's something that would be easy to do. So I will mark that down on my to-do list. If I receive an error that I cannot troubleshoot, what are my options? Yeah, well, that's good. Well, first of all, you see my email right to the left here, robert.foreman@lexisnexusrisk.com. Email me, email Richard Taylor. In our training department, you're also a support resource for you. You can use the HPCC forum so that once you register on the HPCC Systems portal, you can then post a question out there. Many people do that if they get an error they can't troubleshoot, and someone might have seen that error and might be able to help them through. Those are always your go-to. We're your go-to people. The forum is the go-to people, and then also the existing forum you can search, because sometimes you have an error that's already been answered. So as we want that forum to grow and grow and grow and be a definitive reference for many people. So that is probably your best bet there. And look, if we can't solve it, then I always say that I am surrounded by several, the most intelligent people on the planet work for LexisNexis, and why we do such good things with our products. And so normally I can find someone who can find that problem and troubleshoot it for you. Is there a definitive list available for all possible compiler runtime errors? That would be helpful. This question's been asked many times before. There is an internal list that's on, but it's not publicly documented. But if you dig down into the system, you could actually, like in the open source binaries, you can. There was a list I think that was put together, but it was like on the lower level. So the idea you have to ask yourself there is, why would you want to know every possible compiler runtime error, and what would benefit from that? I mean, ECL as a language most of the time is pretty good. I don't know. I mean, having a definitive list of every possible error, and a lot of times people want that list because they want to know, all right, now I got the error, how do I fix it? And the problem is sometimes you can have a boilerplate fix for one of the errors, because there could be maybe 10 or 20 different possibilities that could have gotten you to that error in the first place. So that's where it becomes challenging. Sometimes an error can be caused by multiple reasons, and then you have to just say, okay, which one of these led me to this particular error? All right, let me just do one more here. The rest of these, how can I find out who aborted my work unit? I don't think you can, unless maybe the log files, maybe the system administrator, you can contact that person to find out who did it. That would be my first bet, would be to go to the administrator, and they would have a log there and might be able to track down who aborted it. All right. What errors are being reported that are specific to Git source code control? That's one I don't have an answer for. What errors are being reported that are specific to Git source code control? Okay, well, no, we're working with ECL, so not really sure about what we're asking there, but let me look at that offline. All right, one last poll question, which was, out of the top 10 messages just presented, how many have you personally experienced? Wow, 66% of you had 1 or 4 of those errors in the list. 33% of you had 5 to 9. Thankfully, nobody had all 10. And the other answer is 0. My coding is always perfect. So very good. Thank you for your honesty on that. And good. So you've seen these errors before. Hopefully, I've given you a little bit of insight as to what caused them and how to fix them. And thank you for replying to that poll. I appreciate it. So this is going to conclude our tech talk. As we wrap up here, remember, if you have an idea for a talk, or if you had a compiler error that I didn't have on the list and you think, well, Bob, you should have covered that one, please email me. If you have a success story about HPCC, a use case, if you have an application that you want to demo, etc., please contact us. Our next Tech Talk is April 19th. We have already 2 special guests lined up. We have Russ Whitehead, who's going to talk about developing a custom pluggable HPCC security manager. And then also we have Craig Cooper from our Peoria office, who is going to talk about understanding the ECL Watch work unit graphs. So those of you that go out to ECL Watch and look at those graphs on your work unit and want to know more about those graphs and how to analyze them and what they tell you, Craig's going to be talking about that in our April Tech Talk. All right, so again, all of you out there, thank you so much for attending. Have a great rest of your day. Enjoy your spring break if you're facing that. Happy Easter ahead of you, St. Patrick's Day, and so on. And once again, we will see you in April. Thank you so much.